Welcome to episode 3 of 5 Minute Tech Takes with Naveen. In this episode, we will do an overview of the next generation of communication protocol called I3C or Improved Inter-Integrated Circuit. It is a successor to the popular I2C protocol. Before we jump into I3C, let's have a brief overview of I2C in order to better get a context of the improvements in this new I3C standard. I2C is an onboard communication protocol that is ideal for short distances and low bandwidth. It has a master-slave architecture in which all slaves are connected to the master via two lines. They are serial data line and serial clock line. As the usage of sensors in mobile devices increases day by day, it's becoming complicated for designers to use existing methods like I2C and SPI. I2C is quite slow compared to SPI, whereas SPI requires an extra chip select pin per device. Also, both SPI and I2C don't support hot plugging and automated device discovery. There are many such disadvantages to the existing methods of communication. This is where the I3C standard comes into the picture. I3C is the new industry standard released in 2016 in collaboration between electronics and computer companies with the Mobile Industry Processor Interface Alliance. I3C adds a considerable number of system interface functions while maintaining backward compatibility with existing I2C devices. Furthermore, native I3C devices support higher data rates similar to SPI. The main purpose of MIPI I3C are 1. To standardize sensor communication while maintaining backward compatibility. 2. To reduce the number of physical pins used in sensor system integration. And 3. To support low power, high speed and other critical features which are currently not covered by I2C or SPI. Now that we have looked at the need for the I3C protocol and its overview, let's dive a little deep into its features. First, let's start off with the I3C bus. An I3C device on the I3C bus can have one of the following roles. 1. Master. It is driving the bus. It's the one in charge of initiating transactions or deciding who is allowed to talk on the bus. Secondary master. It initially acts as a slave and can at some point in time gain ownership of the bus. 3. Slave. It acts as a slave and is not able to send frames to another slave on the bus. The device can still send events to the master on its own if the master allows it. Even though I3C is a multi-master protocol, only one device can act as a master at any given time. Bus ownership handover can be initiated by an inactive secondary master willing to control the bus or by an active master if it doesn't want to act as a master anymore. Now let's look at how devices in the I3C bus are addressed. In I2C protocol, each device has a predefined static address configured by the vendor. This can often lead to a collision in an I2C bus if devices share the same addresses. To overcome this issue, each device on the I3C bus has to be assigned a dynamic address to be able to communicate. Once a dynamic address has been assigned to a device by the master, this address will be used for any direct communication with the device. In I2C, we don't have any mechanism to automatically discover devices present on the bus. I3C on the other hand supports automatic device discovery and dynamic address assignment together in one go. In this regard, I3C is closer to a discoverable bus like USB than it is to I2C or SPI. I3C supports the hot join mechanism, which is similar to the USB hot plug. This mechanism allows slaves to join the bus even after it has been initialized by the master. I3C is backward compatible with I2C devices. This backward compatibility allows one to connect a mix of I2C and I3C devices on the same bus. I2C supports a limited range of speeds with a maximum of 400 kilobits per second speed. I3C improves on this by providing a raw bitrate of 12.5 megabits per second. Furthermore, since I3C is using strong pull-up with push-pull mode for transaction, it gives high speed rate with power efficiency. I hope you have got a basic overview of what I3C is, its features and its importance. I3C is a vast topic just to cover in under 5 minutes. So I hope you will check out the curated collection of resources and links provided in the description of this video to get a much in-depth understanding. We have come to the end of this video and you can like and share the video if you found it useful. Also, don't forget to subscribe to Chip in Detail for more such videos.